Hi, I'm Michal Vasicek, and I would like to present you Forge Design Automation for Inventor. I'm working for Autodesk for almost 4 years. My current main responsibility is to make Inventor a valuable part of Forge Design Automation. This presentation is about Inventor on Forge Design Automation. In order to understand this presentation, I recommend you to see my previous AU video for this year. Forge Design Automation Basics. I'm building on top of ideas presented there. How to drive Inventor so it does all the needed changes of your design. There are two ways, iLogic and plugin. Plugin is the thing you know as add-in. Compiled code, driving Inventor through API. I can imagine you have questions like, hey, we have lots of iLogic code already written. Can we use it on Forge Design Automation? We have add-ins written using Inventor API which are driving our models. Can we leverage them on Forge Design Automation? And the answer is yes, but you should be aware of that no UI calls are allowed, like show message box. For iLogic, there are some limitations too. For example, this application object or active document property is not available. I have prepared simple part file in Inventor. It contains width parameter I'm using for changing the model, and I would like to do the same using Design Automation. I'll show you a couple of strategies how you can do it, so you can choose the one which fits your needs the best. I have prepared little iLogic script which sets up width parameter to 1/2 of the inch. You can see that besides setting parameter, I'm also saving the document. You want to use resulting changed model, right? So you need to save the file and then it can be as the output sent to your cloud storage. If you want to use the script, you have to deliver it to your activity somehow. First option may be to deliver it as design automation parameter, besides your box part. Make sure your model parameters specify local name with IPT extension. If you will not specify proper extension, Inventor refuses to open your design as unknown, based on your extension. On the command line, we ask to run Inventor Core Console exe sitting in path defined by engine variable. Using iSwitch, we define what model we would like to open. And there we have to specify full path. If we would specify only model IPT based on our local name, Inventor wouldn't open the model because he can open model only based on the full path to the model. Full path to your input model is specified by args dictionary with name of input parameter in key. In our case, it is model. There is also switch, which is used to specify iLogic script file to be executed. Again, we will use variable expansion using args dictionary and name of the script parameter as a key. Create activity, alias, and we can run the work item. As you can see, we are asked for our input model, but we are also asked to deliver a link to our script. It means we must upload to cloud also our iLogic script. Let me show you how the model was changed. Okay, that worked quite well, but I don't like that we need to specify iLogic script with every work item. What if we know that we are using the same link of the iLogic for all the work items of this activity? Let's change the activity so we can avoid specifying link when running it. Our goal is to deliver iLogic file to Design Automation. And we can use settings section where we can specify ID, URL, and verb. We will keep our ID to be script. URL is our preassigned URL pointing to iLogic script on cloud, the same we were putting into work item argument, and verb is get because we need to download it. We have to change one little thing in our command line. Now as we moved from parameters to settings, we need to change name of dictionary to be settings and not args. And that's it. Update activity, change alias, and create work item. As you can see, script input parameter disappeared. Let's run again and check result. That's all cool. Big advantage of this solution is that even though you are not specifying link to iLogic script every time when running work item, you can still change content of the script before running any work item. Simply because work item downloads the content right before processing command line. But what if I would know that content of the iLogic script will never change between the work items, and I don't want to host the script on my cloud storage and make sure it's available before running work item? For this case, we can leverage Assemblies. We must zip our script together with package contents XML. Just basic package contents XML is enough. And create a bundle out of it. As our bundles are versioned, we need the alias. Then we will edit our activity. There we will delete reference to our script from settings. We set our pre-prepared bundle. We need to change command line. This time from settings to bundles and as a key name of your bundle. Now the path points to package folder. So we need to append file name of our script. Update and create alias. Work item form looks the same, so just run it and check the result. These are three strategies how you can reference your external iLogic script which drives Inventor. Part of the parameter, settings, or inside the bundle. What strategy you use depends on your situation. Let's stay a little while with our third bundle strategy. As we know, the width is now hard-coded to be 1.5 inches. This is not too much useful. What if we would like to change the value for every work item? We want to change width parameter, that's for sure. We want to save the document at the end, that's also for sure. But we want to be able to specify different value for the width. Let's edit our activity. What we need is to define new parameter width. Verb for the parameter will be read, because width is just a value, not a file we need to download or upload. Then we need to pass the value to our command line. To make things simpler for iLogic consumption, we create custom switch called width, and we assign the value from our parameter using our well-known variable expansion. Now we need to change our iLogic script so we can replace hard-coded 1.5 inches to something coming from the command line. For this we can use rule arguments function with name of the switch we created, in our case width. Zip the package and let's create new version of our bundle. Alias update. Now when we create work item we see we must provide the width value, and let's check the result. Isn't that cool? Now we have configurable algorithm written in iLogic. We will move to the next strategy of how to drive Inventor. From iLogic to plugins. Plugins are kind of add-ins you already know. As I already mentioned, there is not allowed to touch any UI inside the plugin. Otherwise, your work item will crash. Plugins needs to be packaged in a certain way, and they are delivered to design automation using bundles. The easiest way how to create plugin which can be used on design automation is to use Visual Studio template extension, which can be installed from Microsoft Marketplace. You can see that solution created using the template consists of 3 projects: debug plugin locally, interaction, and your actual plugin project. There you will write your algorithm. Debug plugin locally will help you to run your code against local Inventor. Interaction can help you to distribute your plugin to Forge Design Automation. We will not use Interaction Project since we are using Visual Studio Code Forge extension to deliver our app bundle and create our activity. Our plugin will do the same as our iLogic. It will read with value from the command line and set the width parameter in document, then saves result. All done by calling API functions. As you can see, there is run function and run with arguments function. Run function is called when your command line doesn't contain any custom arguments. Since our command line contains with argument and its value, we need to fill run with arguments function. Document argument of the function is opened document specified in iSwitch, and map contains all our custom command line arguments. Let's try if our code works by running against the Inventor. I will open box IPT in Inventor and then we will use debug plugin locally project to do the action. Before we can do that, we need to specify our command line, because without it, we wouldn't know what is the value of our width argument. When we run the project, we can see model in Inventor is updated. It's time to move our package to Forge Design Automation. We need to build it. After build, we have zip package ready to be used on Design Automation. So let's create a bundle. Let's change our activity to use a bundle with our plugin instead of iLogic. We need to change the command line. Specify new name of a bundle as a key and delete iLogic file name reference. Since we are not running script, we change switch S to switch AL. Update, update alias, and run work item. Well done. Everything I showed you was using IPT as input model. In reality, most of the automations I saw were using assemblies. So how to work with assemblies? Assembly is not just one file. It's a bunch of files. The best way to go is zip your assembly and use zipped file as input. I have assembly with wall. My wall contains width parameter too. We have to change our activity a little bit. There we need to change our local name, because now we don't want to have IPT extension. When you are using zip, local name represents folder where a file is unzipped. Our output parameter needs to be changed too, because now we need to ask Design Automation to zip result for us before sending it back. In this case, local name is the name of the folder we want to have zipped. Now when we create work item, we need to do yet another thing differently. Since we are sending zip file, how can Design Automation know what assembly to open? What file from within the zip to open? That's what the path in zip is for. We specify path to the file inside the zip. For us, it's wall.w.door.iam. And this is how we can manage work with assemblies. What we have seen today. We can drive Inventor using iLogic scripts. It can be delivered to Design Automation in 3 different ways. URL inside the parameter, which you have to provide before every work item. URL inside the settings, where you don't have to provide link every time, but it's still downloaded during work item processing. And inside the app bundle, the way when you want to leverage Design Automation binary storage and app bundle's versioning capabilities. Plugins. Code which you can write using Visual Studio and debug locally before deploying to Design Automation inside a bundle. Dealing with assemblies inside the zip packages. Zip package is automatically unzipped, then processed using your code and automatically zipped before sending the result. You can use ability to zip whatever folder you like. So if you have some activity which produces multiple files, you would like to zip and send them in one package, you can just save them in one folder and mark the output parameter as to be zipped. To learn more about Inventor on Forge Design Automation, you can check out work with Inventor Core Console in our documentation, read Adam's blog post how to prepare your iLogic to make sure it runs smoothly, and study our open source Inventor configurator, which is based on Forge technologies. I hope you have learned something new and interesting. Thank you for your attention.